Hey everyone, and welcome to part 21 of the Godot top-down shooter tutorial. My name is Joe, and in this video we're going to take the algorithm we wrote in the last video and actually implement it into our game. Not only that, we're actually going to add handling for dynamically updating our navigation grid so that walls are considered obstacles and our units need to get around them. So I'm really excited. We're not going to do collisions with other units like enemies and AI units colliding with each other yet. That'll be an optional next video you can do if you want to implement that into your game. But in this one, like I said, we'll just be implementing the pathfinding and adding walls. So let's get started. So in our last video, we pretty much finished our main A* implementation. We finished the algorithm and we were adding points and connecting them to our navigation grid. We just didn't actually get to making our AI units use that path or create or generate a new path based on that grid and then use that for navigation. So that's what we're going to start off with in this video. And in order to do that, I'm going to hop back into our pathfinding script here. Actually, no, our pathfinding script is good. I'm going to hop into our AI script, and we added this pathfinding variable, which is getting passed down into our unit AI from our map AI whenever it spawns it. So we're already setting this. Now we just need to actually use it. So we just added a function, get new path. So whenever we need a new path, we can call that function within our AI to get a new path. And before I do this, I actually want to run our game real quick. I'll hit Command B, and then I'm gonna, oh, whoops, I forgot, this is good. Okay, so in our map AI, we changed initialize to actually expect our pathfinding node, but we're not passing it in here. So pathfinding and pathfinding. Okay, wonderful. So we're actually gonna get our pathfinding node there. And now if I run this, should be good to go. So you'll notice real quick, if I open our debugger and open the monitors here, our FPS is sitting around 60 frames per second. I just want to keep this monitor open and check it as we start adding new things, just to show that while the algorithm we're implementing may not be the world's most performant algorithm, for a small amount of actors, it tends to work pretty well. So we're staying around 60 right now, and we'll see that when we add this, we're probably not really going to drop any at all. So again, just as a demo to show that this should be fine for most games, and you can definitely optimize as needed. So anyway, with that, let's hop back into our AI. So we have this pathfinding variable, and we need to actually get a new path. And there's a couple places where we may want a new path, and it's probably worth refactoring a little bit of our AI physics process here. But for now, let's just think about two places where it makes sense to get a new path. So when we're in the advanced position, so we're moving to a new base, we definitely want pathfinding there, right? And I think when we start patrolling, we potentially want pathfinding there because there may be obstacles in the way to our patrol location. We probably don't need it in engage because once we're in engage, we're not actually moving. We're just rotating to face the target we're shooting. So I think we can just add it to advance and patrol. So let's do advance right now. And what I'm actually going to do is say var path, and I'm going to set this equal to be pathfinding dot create, or whoops, get new path. And remember, get new path takes a start location and end location. So start location, we can do global position, and then the end location is going to be next base. So we are already passing in the next base to go to. Now, path is going to be an array, right? It's an array of world points to navigate between. So we're going to need to update our logic here a little bit. And here's the thing to know about pathfinding and about A* is that assuming that you get an array with points back, so you can actually navigate where you want to go, the first point in that array is always going to be your start location, which is pretty much the location of our actor already. So we don't want to move towards the first point in that array because it's going to be pretty much where we are exactly. It's instead the next point with index 1 and array indexing, holy crap. That's the point that we're first going to want to go to. So if we have a path with a length of 1, like there's only one point in the array, that point is really just going to be where we are. So it means that we've pretty much finished. We are where we need to go. So we can actually check and say, if path.size is greater than 1. So if there's actually a path for us to go to, we're actually going to change this a bit and say actor velocity equals actor.velocity toward, and we're going to get our velocity toward path of index 1, not index 0 again, because that's where our actor already is, but index of 1. So this is going to be the next point that we move towards. We're also going to want to rotate towards it, so we'll say actor.rotate toward, and this again will be path of 1. So we're going to be moving towards that next point, and we're going to be rotating towards it. And again, right now we are getting a new path every single frame. And the reason or every single physics process, so not every frame, but still very frequently. You could be a lot more efficient about this and just get a path at the beginning and then update it like every half second, or you could update it based on, you could use a raycast or something to only update it when there's something directly in front of you. You could combine this with steering behaviors. There's so many options you can do to create better pathfinding. The reason that we are doing it every frame right now is because 1, it's easy, and 2, when we add dynamic collision checking, we'll already be updating the path every single physics process, so we don't have to have any other fancy handling if something else gets in our way. So we'll automatically update the path as soon as we detect something's in the way, rather than having to have other handling for that. So again, not the most efficient, but it's easy and it's simple, so we're going to do it, but feel free to optimize on your own time. So we are setting our velocity and we are facing towards the next point in our path. Now what we need to do is actually handle 2, what happens if we are done. So previously we were using this actor.hasReached_position. We kind of don't want to use that anymore, I don't think. Like really, if our path is a size of 1 or 0, it basically means we've reached our position. And so what I'm actually just going to do is just say else and just set that there. This is the stuff that we just actually implement. Oh, whoops, I need to actually do actor.move and slide. Nope, move and slide. I guess I don't get autocomplete for that. Actor velocity. So we can get rid of that. And now it should be the case that we are using pathfinding to move to our next base. And so we can run it and see if it actually works and see if our units are moving. And okay, so this is good. It looks like I forgot something. Okay, so this was totally my bad. Apparently in the last video, we totally forgot to wire up our pathfinding node getting passed down, which is my bad. We just because we weren't actually running anything, I think there were some things that got left behind, but we'll fix it here. So the problem is that we're saying get new path, but we're calling it from a base of null. So we're calling get new path, but pathfinding is null, which means it's not getting passed in. And if you remember, we are passing that in from our map AI. So if I come up here, you'll realize we added our pathfinding to our initialized function as a parameter, but we're never actually setting that here. So we need to do self.pathfinding equals pathfinding. And then this will actually set our pathfinding variable here so that when we spawn a unit down here, we're not actually setting it to null. So it should actually be there now. And now if I run this, we'll see that it'll work. And look at this, our units are still going to this base and they're using pathfinding to do it. So if I run this again, notice that they don't all go in a straight line. They are going from point to point. So they're going this way, and watch him turn like that. So they couldn't do that before. They just went in a straight line. We still have some issues like units are bunching up here and some other things, but we're actually using our pathfinding system, which is awesome, really cool. So now that we have that, let's make some more tweaks to make this even better. So if we come into our AI, we can use our pathfinding in our patrol state as well. So let's kind of make some of the same changes here that we just made to our advanced state. So we're still going to want to use this not patrol location reached because we only want to keep going until we've hit our patrol location. But now, same as before, we're going to say var path equals pathfinding get new path. Again, there's room for optimization here. Rather than getting a new path all these times, we could just queue it or store it or cache it or get it less frequently, but we'll just do this like this for now. Same thing, we'll do goal position, and we already have a patrol location, so we will pass in, we'll get a path from our current position to our patrol location. And Then we will set our velocity toward, we'll need to do check our path again. So if path.size again is greater than 1, so if we actually have a path, then we will move towards the first thing on our path, and we will rotate toward it as well. So we'll say path of 1. So get the velocity towards the next thing on the path, turn towards it, and then actually move. And then what we can do is say else. So if we don't have, we can get rid of this has reached position and just assume that if we don't have any other elements in our path besides the single one, or it's an empty array, that we've reached it and we can be done patrolling. So this should be good to see that now once our units hit our base and they start patrolling, that they should be using our pathfinding system to actually move towards their patrol location. So we'll let them, there you go. So he only moved a little bit, but he's still moving. And again, this is using our pathfinding system. So we've got pathfinding working for patrolling. Here comes the enemies. Again, they're just coming right towards the last base, which is a bug, but oh well. But good stuff, guys. So we've got patrolling and advancing towards the next base, both working through our pathfinding. There's a couple issues, though, that you'll see that just kind of make it look not great. All of our units are still clumping up right around our base. So we should fix that. And they don't really patrol that far. So there's just a lot of collisions, and then they get stuck on each other. And there's two ways to fix it. The first way, which we're going to do, is increase the location around the base that they can go to and tell them not to just go right to the base itself, but to go to some other place within the capture radius so they don't always hit each other. We'll do the same for our patrol location, where we'll give them a wider potential patrol radius just to kind of help improve and make it so they collide less frequently. So that's the first way we can fix it, which we will do. The second way, which we won't get to, is you can add a little bit of a collision knockback when they hit each other. So if there's a unit that's trying to get somewhere and there's another unit in its way, if their velocities are hitting each other, you can kind of push them away from each other a little bit, just add a little bit of force, and they'll kind of move away and then still keep moving. Move and slide does not really give you that by default, but it'd be easy enough just to add a little bit of a knockback force. And you'll see this in tons of games where like units collide with each other technically, but they almost move through each other, or they push each other off a little bit. This is super common in other games for this exact reason, is that it prevents collisions or units getting stuck on each other. But just a thought, you can work on that on your own and figure out a way to do that if that's something you want to do. But as far as what we talked about, which is actually changing our patrol location, one thing we can do is come into our map AI. So I think I've got the scene open here. Oh, no, not map AI, sorry. Capturable base. And you'll see that like our radius for capturing is pretty small right now. So we can make that a little bit bigger. So if I open up capturable base, let's get our collision shape, and let's change the extents to be a, what if we did 200 by 200, a square? Actually, let's do 250. Let's just make it a little bit bigger. Why not? So now if we go to our main area, we'll see that we have a big capture radius. So as soon as a unit is anywhere in this radius, they'll start capturing that base, which I think is totally fine. Yeah, shouldn't be an issue. And so what we can then do is, instead of having all of our units go directly to our base, so remember that our map AI, when it's telling our units to advance to the next base, it just gives it the coordinates of the base itself. We can actually calculate some random position anywhere within this radius to tell our units to go there. And that will keep them, hopefully, from basically colliding with each other and all trying to stack up on the base. So if I open our capturable base script, let's add a new function here. And I'm going to say function get attack, or yeah, get random position within capture radius. And this is going to return a vector 2. And what we're going to do here is we're going to get our collision shape first. So I think if I open up our capturable base here, so first we need to get our collision shape. So I'm going to add this as an onReady variable. I'll call it collision shape here. And so within our collision shape, we need to get the shape property and then that shape's extents to get this area. So if we get our collision shape's global position, it's going to give us the center here, right? This is a problem we already were just dealing with our navigation grid, but we don't want the, or if we get the center, we need to either add or subtract half of its extents in either way, because the extents are the full width and height of the rectangle, but since we're at the center, we want to either add half or subtract half, vertically and horizontally, to get a random point somewhere within the bounds of the collision radius. And so we will say var x, and we're going to use random range, and we are going to go from, yeah, we need to do, actually, let's, we'll say var top left. And so what we're going to do is we'll get the collision shape, man, the autocomplete collision shape. And so I'm just going to store this top left corner. So we need to get the collision shape's global position and subtract extents over 2. So subtract the half of the x and half of the y to get this top left corner. So we'll do collision shape dot global position minus collision shape dot extents over 2. There we go. I'm also going to say var extents equals collision shape dot extents. And again, this path, the collision shape dot extents, I'm getting from collision shape, and then mouse over it, we see shape, and then extents. So that's why that's the property there. So we get the extents, and I'm gonna just make this extents. And again, we get the global position, which is the center, and then subtract half the width and half the height to get the top left. And so we want our x coordinate to be top left dot x, anywhere from there to top left dot x plus extents dot x. I can't type that. So we're going to go from the top left x all the way to our top left x plus the extent. So again, anywhere in the width, and then we'll do that same thing for the y. So remember when I said that pathfinding was going to require a lot of math? This is why. So we're going to do that, and then return a vector 2 of x and y. So now we're returning some random position within the capture radius. Now our map AI can use this function to generate a point in the radius rather than just on the actual base itself. So this function is called get random position with capture radius. I'll copy the name, and then here in our map AI, instead of saying ai.nextBase is the base's global position, we can say target base dot this function, which will return another vector 2 within that radius. So now we should see our AI being content to not go right onto the base. So we should see these guys not all stop right on the base. They should stop somewhere within this square, which, yeah, looks like they did. They're still kind of close, but this guy stopped up here. They stopped over there. Let's run it one more time just to see and make sure it's not broken. It's weird that they were all pretty close there, so I just want to make sure. But yeah, you can tell like this guy's going down. Yeah, this is good. So you see how they're stopping at random spots and they're not all hitting each other? Really cool. And as a side bonus, now that our range here is much bigger, we can actually change our patrol radius. Previously it was 50, but remember our extents are 200 now. So let's bump this up to 100. This might cause them to get out of our patrol range, but it probably won't. So we should see it. Actually, let's do 150, honestly. So we should see it now that when they start patrolling, they will go farther away, which should hopefully make them collide a little bit less and make their patrolling look a little bit more realistic. So yeah, there we go, good. So you notice how these guys are actually patrolling a bit. They're moving a little bit farther away, and because they're using our pathfinding to do it, they're not just moving in a direct straight line, which looks a little bit better. So man, I hope you guys are excited. I love this. This is super cool. And even though it's complex, look at just how much it adds to our game. And it's only going to get better now that we're going to add colliding with walls and with other units. Okay, now that I think about it, we're already getting close to 20 minutes. So I think we might only do walls in this one. And then I'll probably do a third part where we can actually do collisions with other enemy units just to kind of save some time. And that hopefully that'll just keep the videos a little bit easier to watch and more separated. Also, sorry, my voice is super hoarse right now. I don't know what it is, so sorry if I sound kind of scratchy or it's hard to hear. But, so, okay, let us update our pathfinding so that we are taking into account walls. And in order to do that, I'm going to come into our main script first and add some walls. Right now we have walls in our game, but they all exist outside of our, where our enemies or players or units are actually going to go. So I'm going to add some walls, and I'll make sure I'm on our walls tile map, and I'm using our wood building, which has a collision shape. And let's just add, just so that we can see, let's add a wall right here like that. And I'll just add some walls around here. It's kind of ruining the aesthetic of our tile map, but that's fine. No harm, no foul there. Just so that we can see some pathfinding in action. Okay, so we've got some walls now, and we should see units try to go around up here. We should see some units hopefully try and go around this way. I'll just add one right here just to see how that works. And yeah, we'll kind of make it a bit challenging. And if I start our game now, you'll notice that even though we're using pathfinding, it does not work because we're not taking into account these walls. Remember, these vertices, we're just adding them and connecting them because we don't have any handling for that. So that's what we'll do right now. So if I come into our pathfinding script, the problem with this is that previously we are creating our navigation grid and we're not touching it. We don't update it at all. So we're going to need something that updates it. Basically, we're going to do every frame. Again, you could be more proficient or performant with this, more efficient. I just combined those two into proficient. You could be more efficient with this by having signals or something to only update your navigation grid when you need to. Again, for ease of use, we're just going to do it every frame. And I'll show you too, again, with our frame rate, that it's not actually going to be a huge hit to it. It's still going to run at like 60 FPS. So we're just going to use physics process because that's when we're updating the position of other things in our game that could act as blockers. And we're going to just say like update navigation map we'll just say update navigation map. And so we need to add this function now. So I'll come down to the bottom here. I'll add it after connect traversable tiles. So function, and this is all stuff that I've worked on and kind of refined over the last year or two. This is not part of the original tutorial, so it's not perfect. It still needs some work, but it'll get you functional pathfinding that dynamically updates to avoid collisions and obstacles and other units, which is so surprisingly hard to find good tutorials on. It blew my mind that it took me so long to figure out how to do this, because tutorials just like always leave it at establishing pathfinding. They never really add in what it takes to avoid collisions and to update dynamically as collisions or as obstacles appear. So that's something I hope this is super helpful for people to have this. Anyway, so we have a function update navigation map. So we'll do update navigation map here. Okay, let's make this function. So remember again earlier when we were looking at the A* functions that come with the A* implementation Godot, that there is a set point disabled. So we're not actually going to get rid of the connections between our points. We're going to keep them all there. We're only going to set the ones that are blocked as disabled. I'm not totally sure if there's a performance difference. It seems like setting points to disabled should be more performant than getting rid of connections, but that might not be the case. I've just always done set point disabled. So if there is a better way, or you've done some testing, please let me know. That'd be great to hear. But we're just going to stick with making our edges, our vertices, disabled. So the first thing we want to do every frame is go through all of our points and re-enable them. So we're only going to disable points that need to be disabled this frame. Again, more efficient stuff you could do here. Instead of going through every point, you could use signals or something to only do this operation when it needs to. But as always, tutorial, we're going to do something that's easy and is not really that inefficient relative. So it's not like we're making terrible decisions here. So we're just going to go through every point and we'll do a*.set point disabled. And we'll have to get the, we're already going through it. So we'll do point and set false. So you use the same function for setting it to be enabled or disabled. It's just this parameter here. So we're setting disabled to be false. So it is enabled. Easy enough. And then once we have that, we are going to somehow need to get our obstacles. So eventually we're going to use units, but for now, the only obstacles that we're going to care about in our game are walls. And potentially we want to architect this in a way that will, as easily as possible, just work for everything else we might want as an obstacle in the future. And we might have other tile maps that should block things or other objects. And so rather than manually passing in walls and trying to use that, what we can do instead is add walls to a group. So I'll select our walls tile map, go to the node tab here, select groups, and add obstacles. And so we're going to use this obstacles group to pretty much add anything in our game that should act as an obstacle for our navigation grid that should disable some points. So what we can do then, now that we have walls in that group, is here we can say var obstacles equals get tree, which is going to get the whole tree of your game, and we'll say get nodes in group. So this is the way you can get a list of all currently existing nodes that have been added to the scene tree that exist as part of a group, and we'll get our obstacles group. And so now we're going to get an array of things that are obstacles. Right now it's going to be an array of 1 because it's just our walls object. And when we get our walls object, it's going to get us the whole tile map. So now we're going to have to go through the tiles that are part of it, and then for all those points, remove them or disable them in our navigation grid. So what we're going to do is say for obstacle in obstacles. And here's where we're going to be able to have some unique handling for each thing. So we can say if obstacle is tile map. So in this case, we're dealing with walls. It's going to be a tile map. Eventually, when we're dealing with other actors like our enemies and our AI, like all units, we could say if obstacle is kinematic body 2D, and do some handling here. But we'll just pass for now, and we'll get to this part later. But just wanted to add this to show you what we'll eventually do and why we're structuring it the way we are. So what we do here for the tile map is going to look pretty similar to what we're doing up here when we're creating our navigation grid. So we're going to get a tile map, and then we're going to say var obstacle var tiles equals obstacle dot get used cells. So again, we only want to get the cells that actually have a wall on them, that our wall tile map has filled in. So we're going to get those tiles, and then we're going to say for tile in tiles. So we're going to go through each of the used tiles. We're going to say var id equals get id for point. And again, this is the really nice thing about having our navigation grid be based on tile maps, is that we can also use that same ID system to get tiles for other tile maps, as long as the cell size is the same, which it is for all of our tile maps. It's all the same cell size of 64 by 64. Yeah. So now that we've got that, we've got the ID, and we can say if a star dot has point. So make sure that this is actually on our grid, which it should be, but we'll check just to be sure. So if a star has this point, if it's in our grid, we can do a star dot set point disabled, and we can say ID and true. So we'll disable it just like that. And I think this is pretty much all we're going to need to do. Oh, I need to actually give it the tile, which will be tile, I believe. So again, we're going to get our tile map, our wall tile map. We're going to go through all of the cells that are filled in and try and map that to a vertex on our grid, our navigation grid. And if it successfully maps, if there's a grid vertex there, we're going to disable that for this frame. And because we're doing this but this physics step, and because we're going to do this every physics step, what that means is that our AI, which is also getting a new path every step, is going to continuously be getting a path that is totally up to date as far as the obstacles in front of it. And so previously when I ran this, we saw that our our allies ran into this wall. But now if I run it, hoping I didn't make any mistakes, we're going to see them go around. And look at this, they even come into this little section here. And they kind of get caught in the corners a little bit. That's kind of to be expected because remember it ends right here, so they're trying to get a diagonal path like right through here. So there's like some buffer room you could potentially add to your algorithm. But if I run this again, we will see that they do in fact correctly navigate using pathfinding to our base, which is so cool. you have now learned how to implement a pathfinding algorithm that not only works and is pretty performant. Let's actually look at our monitor here, and you'll see our frames are still going well. Our frame monitor is still at or above 60, so it's not like, even though we're doing this every frame for every unit, it's not like we're crashing our game. Obviously, this is a very small game. We don't have a lot of units, but this is still pretty scalable for most cases you're going to run into. And we're using GD script. It's not like we wrote this in C++. So just an example, you have a pathfinding algorithm. It has dynamic collision updating, so it'll check and update whenever there are new walls or obstacles. And then the next video will show you how to do that for enemy units as well, so that the AI units will try and avoid each other if possible. But guys, thanks so much for watching. Hope this has been helpful. If it has, a like and subscribe are always appreciated. And I just, yeah, always appreciate the support, guys. Thanks so much for continuing to watch these videos and comment on them. It means a ton. And I'll see you in the next video.